get started.
Okay, well, my name is Alan Journay. I'm guessing most folks here already know that, so that's not coming as news. I'd like to welcome you, of course, to our first SOCAN general meeting of the fun new year 2022, in case you've forgotten what year it is. We're going to get to the program in just a minute. This screen just tells you what you're going to get in about 3 to 4 minutes. So let's go to the next one. For those who don't use Zoom as often as some of the rest of us and may have forgotten some of these Zoom tips, here are a few. Whilst the program is going, please mute yourself and stay muted as Bill is presenting. If questions occur to you as you're going, please open the chat button, which should be at the bottom of your screen. Type your question into the chat box, press return after you typed it in to submit it. And when we get to the question and answer period towards the end of the program, Ellie will be taking the questions out of the chat and passing them on to Bill. You have screen options. If you go to the top right of your screen, you should see view. And you can play around and decide whether you want to do side-by-side speaker or side-by-side gallery. The former gives you the person who is speaking as a large window. Side-by-side gives you the sort of quasi-Hollywood Squares appearance. And as you already know, the presentation is being recorded. As has become our custom, since we've caught up with reason, we acknowledge that are traditional custodians of the land most of us are on today, and that means the Tacoma, the Shasta, the Klamath, and Modoc, and we pay our respect to their elders, past, present, and emerging. The format for this evening, as usual, is going to be a presentation this evening by Bill Gorham. Then we'll have a Q&A in the chat, as I mentioned, facilitated by Ellie Cosgrove. And towards the end of the program, the last 5 to 10 minutes will be Kathy keeping you up to date with SOCAN's activities and those of other groups that are engaged in climate action. It's a great pleasure for us to welcome Dr. Bill Gorham to the SOCAN monthly presentation. We've been meaning to get Bill to come and do this for us for a long time, and we're delighted that he is. We are actually right in his wheelhouse, as you can see, because Bill is a marine biologist. He's had a career in academia, and that was followed by a career in consulting. He is, and we're very particularly delighted by this, Bill was one of the folks from the Brookings Harbor area who engaged with us, oh gosh, a couple of years back now, and is now a leader of the SOCAN, Coastal SOCAN group. He is also, and we're thrilled by this, he's also a member of the board of directors. So we are multiply delighted to have Bill with us, delivering this evening's program. And Bill's going to be talking for, I think, about 35 minutes, following that with Q&A, and then Kathy will be back for the closing remarks on what SOCAN has been doing. So over to you, Bill. Thank you for joining us.
All right. Thank you, Alan. See if this comes up. As Alan mentioned, I'm a marine biologist and have, for a boy from Illinois to have fallen in love with the ocean, it's been a passion for quite a while. As Alan mentioned, I'm retired. And after retiring from full-time as an environmental consultant, I got to get back into looking at climate change and advocating for that. And as part of that, it was kind of the intersection. And as Alan and I were talking, and Alan, Kathy and I were thinking about presentations, trying to have a chance to look at the ocean perspective. And I make a distinction on greenhouse gas emissions because it's really the fundamental tie into a number of aspects about the ocean perspective. So let me get on with that. Now, this is a picture you've probably seen many times, and that just shows kind of a sideway view of the atmosphere. And we know that there's a very thin layer there. The greenhouse gases get up there, and recognizing this, probably knowing that 162 million tons of greenhouse gases every day going up there is an open sewer, as Al Gore likes to say. And we recognize that it's had a lot of impacts on land. You know, there are 4 countries that hit over 50 degrees centigrade, 122 degrees Fahrenheit this last summer. And so we're real familiar with that sort of stuff. But that's on land. Recognizing that the ocean represents over 70% of the ocean, of the surface of the planet. Maybe we should call it ocean rather than Earth, but that's my own bias. Recognize that 97% of the water on the planet is in the oceans. There's a lot there. So what I wanted to talk about is ocean heating, wondering what causes it, what effects does it cause, but then also talk about ocean acidification. Ocean acidification is kind of the poor stepchild. Most people don't think about it. So I want to talk what it is, what causes it, and its effects. So you might have seen this slide before too. It's one that recognizes that if the ocean is very, very valuable to us. 93% of the extra heat that's been trapped has gone into the ocean. One of the estimates that has been presented is that, well, if it weren't for greenhouse gases, our planet would be about 1 degree Fahrenheit. So because there are the greenhouse gases in balance, it's more about 59 degrees Fahrenheit. Well, the estimate was made that if it weren't for the heat being trapped by the ocean, our planet would be about 120 degrees Fahrenheit, which, going back to that earlier slide, that would be the entire Earth, and that would be the average. So the oceans have been very, very valuable and very, very helpful for us to maintain what we've got, but they are changing, and that's an issue. You might have seen this before, where ocean temperatures continue to rise. 2021 didn't quite make it as a new record. 2020 was a new record last year, the year before. It didn't get to be a new record because we had a slight La Nina effect, which typically is associated with a cooler ocean. And so the suggestion was, if it weren't for La Nina, we would have had yet another record in the ocean. Now, it's not just the surface that's getting affected. That increased temperature is being spread all the way down to the deepest layers. It is kind of disturbing that half of the increase has happened in less than the last 20 years. So from this, we see that there's so much heat being trapped by the ocean, we're actually baking in, if you will, changes that will continue for quite some time in the ocean. Now, the effects of the extra greenhouse gases, you're probably familiar with many of these. We know the extra heat means more evaporation, leading to heavier downpours, sea level rise, current changes, coral reef death, algal blooms, anoxia. It's also the CO2 in the water, not just all GHGs, but CO2 in particular. It makes the seawater more acidic. That means shells and reef skeletons are more difficult for animals to build, and the impact is especially hard on the larvae. Now, what about locally? We know that there are records that happens more often than it has been, but unusually warm water are closer to shore than they have been. There's a correlation between algal blooms and more warm water, and algal blooms, the right ones or the wrong ones, can lead to domatic acid, which has its consequences. Mobile species move around, the winds change, rainfall, stream flow, that can lead to more stratification. And with more stratification, where you have less dense water sitting on top of more dense water, it means that you don't get the mixing you'd expect, which can contribute to dead zones. And again, we can have the impacts to larvae, which it was evident a few years ago where there was no larvae set in oyster hatcheries. So the impacts are significant. You're probably aware that the impacts to the atmosphere are really more strongly felt in the poles than at the tropics. And it's kind of the opposite for the oceans, where the tropics are where the effects are the strongest. And it's at the surface level at this point, certainly. So with the warmer water, we get more atmospheric energy in the atmosphere. You know that it's more intense and rapidly intensifying storms that have higher wind speeds. Now, this is an interesting shot from Hurricane Ida. And Hurricane Ida was amazing. 3 days before it hit land, it was a tropical depression. In 3 days, it went from a tropical depression to a Category 4 storm. So a Category 4 hurricane. So it was pretty amazing that it happened that fast. And with the increased water temperature happening, it affects the speed with which the storms intensify. It also gives more water vapor, leads to more precipitation. And it also makes the storms a little bit more squirrely. They don't move as fast. Now, here's a track of Hurricane Harvey a few years ago. And the interesting thing, aside from it rapidly increasing, it kind of wandered around Houston and around southern Louisiana. The interesting aspect about that, in most of that area, it was considered a 1 in 25,000 year rain event. In some areas there, it was 1 in 500,000 year event. So it's happening way more commonly with a lot of rain. And one space, there were 5 feet of rain in Nederland, Texas, outside of Houston. 5 feet in one storm. That's tremendous. And with Ida, it was not just resulting in rain down in the Gulf area. That went all the way up to New York. And here's some pictures from Pennsylvania. There's stories from people that died in New York City being flooded out by basement apartments. Again, that's basically unheard of. So we see other things that are happening from the warm water. Sea level rise increases. You may be aware that when seawater warms, it expands, and about half of the sea level rise is due to simply the expansion of the water as it warms. Here's a picture of Coos Bay, and it shows what the estimate of the sea level at high tide is right now. With a small increase in sea level, about a foot or so, there are some areas that would be impacted more than they are right now. But, and we'll talk about it in a minute, some extraordinary changes that could happen if some tipping points happen. 10-foot rise in sea level would basically drown the airport, drown much of the North Spit. It would also mean that when there are storms that are coming through, remember they can be more intense. They're going to have more of an effect from the storm surge, and other things. So it becomes a very, very compounding effect. It also can drown some of the marshes and seagrasses areas. So it's not a simple impact. Now, I mentioned something that could happen that would be unusual, and you might have heard of the Thwaites Glacier, the Doomsday Glacier that is talked about. Matter of fact, Dr. Pettit at OSU is one of the researchers that has been studying the Thwaites Glacier. And the concern is that there are strange things going on there. Now, the Antarctic ice sheets, the Thwaites Glacier being one of them, is unusual because it's actually up on land. And it comes down to the coast, and where it's rounding, it's kind of held there by a little bit of a lip. And the situation is you have this rounding line, which keeps the glacier slowly but surely going out. The problem is with ocean currents being warmer, they're actually working to melt the bottom of the glacier, which by having it be melted, it then isn't being held against the ground as much as it was. And if it goes far enough, then it can kind of speed up. Right now, the Thwaites Glacier contributes about 4% of the global sea level rise. Now, if suddenly it becomes a much more freely flowing glacier, it can change radically. The suggestion right now, we're probably looking at a foot of sea level change by 2100. If this sort of keeps, if it makes that dramatic change and becomes sort of detached from its grounding line, that could change to be 6 feet by 2100. Unfortunately, there are also people that say, well, that's not even the worst case scenario. So that picture before of Coos Bay at 10 feet, there is a possibility that that isn't beyond the possibilities by the end of this century. So other things we've got from warmer water, it leads to less Antarctic sea ice, and that's a positive feedback loop. Well, what's a positive feedback loop is basically where you have a change that as it comes into effect, it causes more of that change. As you probably have heard, if you have less ice, it's going to have less, it's going to be reflecting less of the sun, and that it exposing more of the open water, which then can absorb more of that sunlight energy, which then leads to more of the ice melting. And that is a forward feedback loop. So it's not a feedback, it's a feed forward loop. Now here are pictures you might have seen where the brown line around the white ice is the median extent of the sea ice between 1981 and 2010. And it's now the summer minimum is significantly smaller. Now it's of excitement to some people in the shipping industry, particularly in Russia, because you can see that Russia now has an open sea lane all around its borders so that it can move cargo much more easily from the west to the east or east to the west. That means that the animals that are in there that are used to a very, very quiet ocean, a naturally quiet ocean, they're going to be subjected to more sounds from shipping. There's going to be more chances of pollution from the ships that are going through there. So it goes beyond simply warming it up. It's going to could have some substantial effects. Now, the other thing about warmer water is it holds less oxygen. Now, less oxygen means there's less oxygen available for animals, and that can have some significant effects. Again, bringing it back home to what we have here off our Oregon coast, since 2002, when it was first reported off Oregon, we have dead zones. Well, the researchers prefer to just say low oxygen, so it's not necessarily, it'd be hypoxic or anoxic levels of oxygen. And as I said, it was first reported in 2002, 2006, 2007 was the most extensive one, but it happened again in 2017 and 2018. And in fact, it's a regular occurrence. It was interesting, last summer, the winds were consistent, and they were consistent and persistent. And the projection was we would have another dead zone event. Apparently it didn't materialize, but it's something that is expected. Now, rather than having me do a lot of talking, let me show you this video, which is way more effective.
Some can swim away. Some try to crawl away. Others might propulse away. Many are just too slow or stuck.
Dead zones of low oxygen water kill crabs, fishes, and other marine life. And the recent annual occurrence of dead zones in the nearshore points to dramatic changes in our ocean environment. Today, we're just 2 miles off the Oregon coast, monitoring ocean conditions. It's hard to believe, but the water right underneath us might not have enough oxygen in it to support most marine life.
Prior to 2002, dead zones, which are areas lacking in oxygen, often called hypoxia, were not reported in nearshore waters off Oregon and Washington. But since 2002, hypoxia has occurred here each summer to varying degrees. How does a dead zone form? Each spring, our coast is dominated by winds that blow from the north to the south. This wind is the engine behind ocean currents that move pole water up from the deep ocean to the coast. The upwelled water is naturally low in oxygen. This upwelling can be seen from space as a band of cold water that forms along the coast. Upwelling currents also bring nutrients to the surface of the ocean, where they fuel the growth of microscopic plants called phytoplankton. Phytoplankton bloom and fuel a productive food web in the upper ocean. The phytoplankton eventually sink toward the seafloor, where they decompose, using up oxygen in a layer of water that has less oxygen to begin with. This combination can give us dead zones that can envelop much of the coastal ocean.
This underwater footage, taken by the Oregon Department of Fish and Wildlife using a robotic submersible, shows a healthy reef near Cape Perpetua. Under normal conditions, these nearshore waters are home to a productive ecosystem of fish, invertebrates, and plants. This footage was taken at the same reef during a hypoxic event. There are no fishes in the reef because they have moved away to find oxygen. The slower moving animals cannot move and suffocate. Dead zone leaves have changed the ecosystem behind. The changes we are seeing are challenging us to find new ways and to forge new partnerships to study and monitor our coastal oceans. We are now deploying sophisticated new buoys and ocean roaming robotic gliders that provide data on ocean conditions in near real time to the public. Both ocean currents and winds are shifting with changing climate. Understanding these shifts and their causes helps us to assess the impact of climate change on coastal oceans and the abundant life they contain.
So as you can see, it's an area of active research and study, and unfortunately, it's something that seems to be persistent. Now, as was mentioned there, the change in the winds can affect major ocean currents, and you might have heard about that. Now, without getting too much into the oceanography, let me explain a little bit about one of the things that when I studied oceanography, it was really fascinating. I wasn't aware of it. They call it the Great Ocean Conveyor Belt, or in fact, thermohaline circulation. Basically what it means when seawater is moving from, say, the African area to over to through the Caribbean, that is part of the Gulf Stream. And as it's moving along, it's carrying the heat that it picks up there on up along the eastern seaboard for the US and on over to Europe. And it's very effective at moving that heat from the tropics up into the northern latitudes. Now, what's interesting is that if it weren't there, we would have a much colder eastern seaboard and a colder Europe. The concern is that there's evidence that circulation is slowing down. Now, when the water's going across the tropics, going over, in this case, to the Gulf of Mexico, it's having a lot of its water evaporated out. So that means it's leaving salts behind and it becomes more dense, but it's also staying pretty warm. As it goes along the eastern seaboard, it's cooling down, and yet it's moving along reasonably well. As it gets farther up, it gets chilled enough so that some of the water will start freezing. And as that ice forms, it leaves the salts behind. So as it gets colder and as it gets more dense, eventually, as you'll see in the up part, it will start to sink. And so it sinks down to the bottom channels there, going along the mid-Atlantic ridge, all the way down to the circumpolar regions around Antarctica, as well as into the Indian Ocean, up through the Pacific. And so you have these deep ocean currents that are very heavy, and they end up having low oxygen because as they're sitting there, what organic material is there, it will start to decompose, but it will be very, very high in nutrients. Now, a concern is that little part that we have for the Gulf Stream. It's called the Atlantic Meridional Overturning Circulation. And that little part of it has been suggested, it evidences that it is slowing down. How quickly it would slow down, how much it would slow down is still being monitored and debated. But as you can imagine, if that slows down, so that heat that's being carried from the tropics up to northern parts of North America and to Europe, if that slows down, that could have major impacts to the climate in those areas. The circulation is, again, there's a lot of modeling that's going on, but it's important to recognize that it's something we're really watching. that would be a tipping point if that happened. And unfortunately, there are records and the paleoclimatologists look at that such changes have happened and relatively quickly. So other things that warmer water can have effect on is coral bleaching and leading to reef death. So you can see on the left side is a nice bright white coral, which if you know corals, that's not what it's supposed to look like. The bases of it are sort of brown, and in the back on the left, you can see a nice healthy brown coral. Corals are interesting. You may know that they have zooxanthellae, single-celled algae that live in their tissues. It's a really nice symbiotic relationship because the corals give the algae a place to live. They also produce carbon dioxide as they respire, as all animals will respire, and that gives CO2 for the algae to use. The algae get a place to live and they have leaky cells, so they produce sugars that the corals will have. So it's a really good relationship. Problem is when things get too hot, corals react by pushing the algae out. So they remove the zooxanthellae, leaving behind the white of the coral, of the reef below them. So you're actually looking through the tissues of the actual coral. Now that's a problem if it goes on for too long, because the corals are requiring that they're used to having that extra sugar from the zooxanthellae. Give it enough time, then the coral will die, and the difference will be it gets covered by algae. So you can see in the left side, the difference between the front and the back. On the right side, you can see that that can be fairly extensive. Unfortunately, there have been some pretty substantial coral bleaching events, especially within the last few years on the Great Barrier Reef. The expectation is that within my lifetime, which we're the same age as many people on the call, it's not that long, that there will be no coral, no warm water, shallow water corals left, which is disturbing to me because that means I can't show my grandkids what I got to see as a young person. So to give a sense of what's at stake, recognizing that this is the upper picture here is a shot from January this month, middle of this month, and that shows the potential for bleaching. And because it's the southern hemisphere, that's their summer, you don't see too many areas that are orange or red, and didn't see, maybe over to the near South Africa is an alert level 2. But if you look at the lower picture, that's the heat stress for the January through April of this year, projected what's going to happen, a 60% probability of coral bleaching. You can see a massive amount of the coral areas that could be bleached. So the impacts can be substantial. And it seems to be, well, because remember I said that there were, that the temperatures are kind of baked into the ocean. These are one of the effects that probably are baked in. Now, another aspect about the warmer water is that mobile animals will move to other locations. There's an interesting story of a fellow that was up in Massachusetts fishing for striped bass, which was a really good place. And he pulled in the upper picture, that odd looking striped bass, which is not a striped bass. And that's a sailfish that only occurs in the tropics. So they are moving around, taking advantage of new areas. In the Arctic, the Chinook are coming into areas that they don't normally occur. So that can be a good thing if you're trying to catch Chinook, but it's not a good thing if the Chinook are leaving where they are typically occurring. On the other side, some animals will seek cooler water as they get away from, as they need that cooler water. They'll go deeper or head towards cooler northern waters or southern waters away from the equator. Now that's not only the prey, but it's also the predators. The picture of the fellow on the right showing the right corner is holding a Humboldt squid. As you can see, they get to be pretty good size. They're also voracious predators, and they apparently have a great, they really like hake, which is another name for the whiting. And the whiting is one of the major fisheries off our coast here. They can consume massive amounts of this stuff. They obviously grow up to be pretty good size. So that could have an impact on the fisheries. Could also have an impact if you go out and fish for Humboldt squid. You can make quite a few squid, or shall I say calamari steaks, out of one of those guys. Mobile animals have other, or the impacts have other impacts. The warm water has other impacts. The stream temperatures are going to change as the stream temperatures change. It changes the signals to some of the migratory species. Salmon are waiting until the stream temperatures cool down enough before they'll go up to their home streams and start spawning. If they wait too long and you have the winter storms, that heavy winter storms that might come early or they're substantial, the animals, the adults may get washed back down and they're never able to spawn. On the other side of it, when the young, the smolt, are ready to leave the streams, they wait to get they'll use the temperature as one of the cues. If it's warmer than it should be, they may leave early. They may not be fully developed, or when they get out to the ocean, the food that they're used to isn't available because it's not part of their normal time. Warmer water, also related to domainic acid, as I mentioned. They tend to occur when the water is warmer. You may have seen signs like this, warning against toxic razor clams, and you see that there's the fishing of razor clams, digging of clams is shut down at different times in different places. Domainic acid is caused by a diatom. It does a neurotoxin. Symptoms from simply, stomach problems to seizures or memory loss. It's also known as amnesic shellfish poisoning. Occasionally, it does kill people. As I said, it's more common with warmer waters, and basically what happens is that filter feeders, clams in particular, but other animals that will filter out stuff, will filter the diatoms. They'll concentrate the toxin. Crabs or fish or anything else that eats the crabs, the clams, or other filter feeders will then concentrate the toxin. Typically for us, crabs will concentrate it mainly in the gut, which is a good thing, and it doesn't typically get to a high enough level to harm us if we eat the crabs. On the other hand, when the crabs are harvested, if the domainic acid levels are too high, they are not suitable for export to the Asian market that has a high premium for fresh whole crabs. So if the domainic acid is high, it's still edible for us, but only after it's been cooked, cleaned, and you eat just the meat. The problem is if you use the broth that the crabs are boiled in as part of your meal, as is common in many of the Asian cultures and cuisines, then it's a problem. And it's not just us, it's other mammals, it's birds that can get domainic acid poisoning. So you can see that it can have a big effect on commercial, recreational harvest, whether you're talking about crabs or clams or others. Now, warmer water can also lead to an increase in divorce rates. And it's not simply because people go on longer trips for fishing. In this case, we're talking about black browed albatross. And if you're a bird person, I would really like you to tell me how you can tell if one mate is changed from another, because they pretty much look all alike to me, but that's just me. Now, there is an interesting thing about this and many of the other shorebirds is they're monogamous and they have a very low divorce rate. However, with warmer water leading to less phytoplankton, fewer fish, it takes a lot more effort to get enough food. That means that can associate with a lower reproductive success. That means that the female will try to find a different mate to have a higher reproductive success rate. Although the researchers that did the work, and it's very, very recent that it was published, they say that the female may still have the same reproductive success rate, but just the stress of going out and getting the food and dealing with all those issues will make the divorce rate actually increase somewhat too. So that's enough for the hot water, but ocean acidification. And I said, that's kind of the poor stepchild of the greenhouse gas pollution. What is it? It's the oxygen, it's the carbon dioxide going into the water. And fortunate that's happened that 30% of the CO2 that we've emitted has gone into the ocean. And in a little bit of chemistry, just to help explain it, when the CO2 and water get together, they produce carbonic acid. When carbonic acid sits there, it actually comes apart and it makes these hydrogen ions, the H+, and bicarbonate ions. Bicarbonate is the buffer for the oceans. You probably have used sodium bicarbonate in cooking or for acid indigestion. Now, the thing about bicarbonate is that it is the stable form. It really likes to be around. So by being the most stable, if there is any carbonate, we'll talk about that in a second, but if there's carbonate, the extra hydrogen ions grab it, come together and make more bicarbonate. So extra acidity means less carbonate, which is a problem because marine animals will, many of them that will use to make their shells, corals in it as well, will use the carbonate, combine it with calcium and make calcium carbonate for their shells. If there is less carbonate around, because it's scavenged and pushed into bicarbonate, then it's harder for the animals to make their shells. Now here's sort of an overall picture showing the CO2 in the air, in the water, carbonic acid. And then down in the lower right corner, we see the hydrogen ions that instead of being available for as bicarbonate, they get scavenged away. There's less calcium, fewer shells. Now it's interesting, you might have seen this Keeling curves that's called on the left, where CO2 increase in the atmosphere, same parallel with CO2 in the water, and that parallels pH changes in the water as well. Just for what it's worth, the pH is an inverse ratio. The lower it is, the more acidic it is. And again, taking it out to a local spot, you can see that off the Columbia River, off Newport, Port St. George, there are a lot of places along our coast where the pH has gone way below what it should be. And in fact, just overall, it's already just dropped by about 1/10 of a pH unit. Now, that increased acidity really can affect things, especially the larvae, because here's a picture of oyster larvae that one is under normal circumstances. The lower one is just 1, 2, and 4 days. You can see that the larvae can't form their shells. They're not going to survive. That was the outcome of the acidification event that affected the oyster hatcheries on the upper Oregon coast. Now it happens to corals as well. They can't build the reefs. Adding that to the heating to the bleaching makes a double whammy to that. It's also interesting that crab larvae use they have their some of their sense organs are part of their shell. And if they can't make their sense organs, they can't function properly as well. Now, salmon are affected by this in several different ways. Salmon love pteropods. Pteropods are really cool looking swimming snails. And you can see that the snail shells, in this case, over a period of 45 days, if it's in acidic water, it slowly but surely deteriorates, which means it dies. So there would be less food for the salmon to survive. They can't eat the zooplankton that can't form the cells. The other thing with salmon is that they are directly affected by acidification because they lose their sense of smell. And when they can't smell very well, they use that to avoid predators. They also can't find their way home. So between the warming of the water and the acidification, salmon are not going to be positively affected with that. Now, there are things we can do to reverse the effects of this, but now we're going into the same stuff we keep talking about. We need to get away from oil and gas. We need to get to renewable energies, change our food habits, restore affected landscapes. The same thing we keep hearing. Why do we need to do this stuff? And I used to have a sense of why we need to do it. And the other side of it is kind of interesting. There's a report that was released a couple of years ago, and it has been represented very effectively by Jane Lubchenco who is a senior biology professor, marine biology professor at OSU. Actually, she's on loan to the Biden administration as the administrator for NOAA for oceans and climate change. In this report, they identify 5 different ways that the climate change can be affected by the oceans in a positive way. Increased renewable energy in transport, marine ecosystems, fisheries, and one which I don't really care for is carbon storage in the seabed, and I'll talk about that very briefly later. Now, the estimate is that by 2050, we're going to need about 56 gigatons of CO2 equivalent in reductions of greenhouse gas emissions. Of that, 21%, 11.8 gigatons, could come from these 5 different aspects of the ocean. Now, the biggest part is ocean-based renewable energy. There's a big push, and we can talk more about, and I believe the next session, the next monthly meeting for SOCAN, going to have Shannon Souza come and talk about offshore energy as well as other renewable energy for here in Oregon. This ocean-based transport has a part, and as I said, the carbon-based storage is one that is very controversial. But in any case, the offshore renewables can be a big deal. Whether you're talking about wind or wave energy, tidal energy, there are all these things that can happen, and it's also very big here. By the way, PacWave is part of OSU. Ocean-based transport, it's moving towards batteries, low carbon synthetic fuels, green hydrogen, all these things are part of it. Coastal marine ecosystems, basically it's we conserve and restore things like mangroves. Well, we don't have a lot of mangroves here, but we certainly have some productive sea marshes. Seagrass beds are important as well. Seaweed aquaculture could be an offshoot of the offshore wind and others, but then protecting marine fauna. Looking at fisheries, doing proper harvesting and controlling that effectively. An interesting aspect about offshore wind could be leading to marine protected areas, but are by default. So that can also help. So you can see there are a variety of things. This picture kind of summarizes them all together. The ocean can be a significant fight, sort of weapon in our fight against climate change. Last thing I mentioned is carbon storage and seabed. I don't like it because it's geoengineering, and that's a whole nother topic. So with that, I want to leave you with these ideas. What can we do? And I emphasize vote, and that's not something you haven't heard a lot about. So get yourself educated. Talk with friends and family so you can have the proper information to do that. Make your lifestyle changes, run for the office and win. Join groups like SOCAN and others, write letters, guest editorials, and your elected representatives, but vote and keep doing what you're doing. With that, I'll open it up for questions.
Awesome. Thank you so much, Bill. That was really great. Lots of really good information, and I'm sure everyone's just kind of letting it soak in a little bit. So feel free to continue to put your questions in the chat. I do have a couple here that we can address while we're waiting for some more to come in. Kathy and Alan wanted to know what proportion of marine fish use coral reefs as nurseries?
I don't have a specific number, but it's substantial. One of the things, it sort of depends on the area, but coral reefs, seagrass beds, other mangroves are other really good examples of physical structures, ecosystems that are critically important to the nurseries, to be nurseries for all sorts of fish species and other and other animals. So yeah, my sense is on the order of 50%, but that's a guess.
All right, thank you. And Ray Millette wants to know what's happening to the kelp beds off of the US Pacific coast.
What's happening is they are disappearing, as you know. Why? There's a variety of reasons for that. One is with the increased temperature that seems to be affecting it. There has been it's called a wasting disease that has affected the echinoderms, a lot of the starfish and sea urchins. There has been a reduction in some of the predators on the sea urchins, so that you have what they call urchin barrens, where the urchins are so common that they are actually grazing away virtually everything, especially the young kelp. So there are a variety of factors, but it kind of emphasizes the fact there are a whole bunch of things going on, and we can attack each individual things, but we have to do them all.
Yeah, absolutely. Hogan asked the question that we're probably all thinking. So given all of these challenges that you talked about, how can we frame this crisis for the masses and talk to people about it?
That's an excellent question, one that we continue to wrestle with. My closing slide was basically kind of the essence of it. It's one of the things is to maintain a positive outlook on it. And part of that is to be educated, see how things are changing, see what activities are occurring. We had the infrastructure bill, which has some of the some money going toward climate change. We see some progress from COP26, not as much as we'd like. One of the things that is a positive outcome is that it seemed like there were more young people who are saying, this is my life, this is my future. We have to make changes, and getting everybody from the people on this call to the people that are in high school now to say, we have to make changes. And part of voting and electing people that will actually make those tough decisions, that's what we have to do. One of the interesting aspects about it is it's very, very complicated. Something as simple as offshore wind. Well, you put the platforms out there, but you have to bring it to shore. You have to have the infrastructure to get the electricity to where you need it to be. We're talking about lots of electric vehicles. You have to produce the electricity. You have to distribute it. You have to get chargers. All of those require a lot of attention, a lot of work. So it's a matter of all hands on deck, look at all the options we have and work hard at it, and don't give up. Make sure you keep that hope, because that's what's going to make a difference.
Yeah, definitely. Thank you, Val, for reminding us all of that. Ray Millette wants to know, are there methane hydrates in the seabed that could be another positive feedback?
There are, from what I understand, and for what it's worth, methane hydrates are sort of crystalline methane. And if you think of methane freezing and it'd be under extreme pressure, which is in the deep ocean, you have both those conditions. There are people that were saying we should go mine them, and we would have a very rich supply of methane, which for what we know now is not a good thing. The issue is, would the heating of the ocean be enough to reduce the conditions that are keeping it as a frozen, if you will, a frozen methane? From what I've understood, the conditions are far enough away from those that would cause it to volatilize, essentially, that it's not as high a chance as some of the other potential tipping points, unfortunately. I mean, I guess that's good, but when people talk about mining them, that brings up an entirely different set of issues.
Aaron wants to know, in recent years, when I visit the coast, I sometimes see large numbers of starfish or jellyfish on the shore, and the sea lions vanished for a bit from their longtime spot. Is this due to dead zones?
It would be very difficult for me to answer that question in terms of there's so many factors that could affect all those. I will say, though, that one of the projections that I had read is that with continuing warming of the oceans, and especially if we continue with the uncontrolled, unregulated overfishing that we've got, we could see a population increase in jellyfish, which would be good for the turtles that live out there and come and feed on jellyfish, but it would certainly have other impacts that we wouldn't want to have. So the changes in distribution and activity of sea lions, up to a lot of factors, but since they can be affected by domain acid, that could be a factor. So it's a very, very complicated question and a good one though.
Next question is from Karen. Can you name some organizations that we can learn more and advocate for?
Probably I could list off a whole bunch, but probably the very best resource for that is to go to the SOCAN website. And there is, I maybe let Alan or Kathy give you a more direct direction to that, but the resources there are fantastic. So it's the resort, it's the everything from SOCAN as a local to the climate reality, of which I'm a member, Alan's a member. We have, who else? Hogan's a member, and it's basically getting people active, but the best resource is SOCAN website. SOCAN.eco, in case you don't have that.
Yes, and Kathy just put that in the chat. Thank you, Kathy.
Yeah.
All right, I think we have time for one more question. We've got one from Ray S. Were or are kelp beds significant in carbon sequestration? Loss of beds due to increased water warming is another feedback loop issue.
Yes, and simple answer. And to give a one-word answer to that, almost suggests it's not giving it credit that it's due. It's a big, big, big deal. And in fact, one of the solutions, didn't really look at it in great detail on the report I mentioned, is the possibility of seaweed aquaculture, specifically so that the seaweed would capture the CO2, incorporate it into tissues, and then would actually be sunk into the deep ocean. And that'd be a way of accelerating the movement of CO2 into tissue into the deep ocean. I'm leery on that because we don't know very much about what happens in the deep ocean. We know more about Mars, the surface of Mars, than we know about what's in the deep ocean. So whether they're going to do mining of methane hydrates or lithium or other nodules of very, very rich resource metals that we need for our transition, or putting kelp down there, the consequences we really don't know. So, but that is a good thing to do.
Well, that's super interesting. Thank you so much, Bill. And with that, I'm going to hand things back over to Kathy, and she'll wrap us up.
Thank you very much, Bill and Ellie. We're going to give Ellie just a second to say a few things about the Master Climate Protector before we go into some other activities that are happening.
Yes, so we still have some room in our Master Climate Protector class for 2022. We're going to be starting February 9th. That's Wednesday night. So, and then we'll run for 10 Wednesdays, 10 consecutive Wednesdays from 6 to 9 p.m. And we're meeting virtually on Zoom, so you can do it from the comfort of your own home. Don't have to drive anywhere, which is nice. And that's good for our planet and our oceans. So if you're interested in the course, you can visit the website, and that's socanmcp.eco, and I'll put that in the chat in a second. And you can find more information about the course there, and you can register from there as well. You can also email me, and I'll put my email in the chat as well if you have any questions. Thank you.
Thanks, Ellie. I'm going to spend just a few minutes going through some SOCAN activities. And if you want more information, everything I say is at socan.eco/events. and that's the calendar. So SOCAN is divided into 5 programs with different projects within each program. Our program areas are education, government, natural resources, transportation, and community engagement. And not all of those groups have meetings right now, but the following are some of the meetings that are going on. In the government group, the county and city project is a fairly new project, and the main group meets on Thursday, January 27th. And if you go to the SOCAN calendar, you'll get the link to the Zoom meeting. So that's this week. In addition to the main meeting, there are different action teams. So if somebody lives in a town and wants to be involved in action in your town, the Medford Action Team is meeting on Friday, February 4th, and the Jacksonville Action Team is Monday, February 21st. The Medford group will be on Zoom, and the Jacksonville group will be in person. The federal and state project will meet on Monday, February 14th, and the links to that meeting, which is a Zoom meeting, are on the calendar. Natural Resources Program, the Forest and Fire Project, will meet on Wednesday, February 16th, and again, details are on the calendar. Coastal SOCAN has its monthly meeting, and you might want to check this out. It definitely relates to what Bill was talking about tonight. Wednesday, February 16th, it is on Zoom, and they're going to view the documentary Chasing Coral, led by a discussion. So if the coral issue is of interest to you, you should mark your calendar and join them for that Zoom. The link to that Zoom is on the SOCAN calendar. SOCAN's February meeting will be on Tuesday, the 22nd. And as Bill suggested, Shannon Souza is going to join us with a focus on renewable energy as a way to adapt and mitigate for climate change in the Pacific Northwest. She does a lot of work. Well, she's the CEO of Ocean and does a lot of work with offshore wind. So we're hoping she's going to share some of that with us. There are other projects that don't have meetings scheduled right now, but if you're interested and you can't read fast enough to figure out who you should contact, just send me an email, Kathy@socan.eco, and I'll connect you with the right person. We like to connect you to things other groups are doing. So the first one is Incendios Forestales y la Salud Comunitaria. And that is a presentation by Unite Oregon, the Rogue Valley chapter, and Beyond Toxics. And that is linked on SOCAN's Facebook page under events, if you're interested in that one. Southern Oregon Citizens Climate Lobby meets monthly. Their next meeting is February 12th. If you want more information about them, dylanhenson@gmail.com is the best way. And again, if you can't remember that, send me an email and I'll connect you. ROCPAC, Rural Oregon Climate Political Action Committee. It's our voice on climate action. Legislature is getting ready to start. Encourage you to look at their webpage. And if you are able to help support them, please do so. A big thanks to Bill Gorham for all the information he has in his head that he was able to put into understandable words for us tonight. Really, really appreciate it, Bill. Thanks, Ellie, for doing the questions. It's so helpful to have you monitoring those and asking the questions. And thanks to all of you for joining us. This action that we want to take, that we need to take, only happens if people like you learn more and lead others, talk to others. Like Bill said, talking to family and friend is one of the best ways to help make a difference with climate change. So we hope you'll look for opportunities to share the information you learned tonight with others, support the Ocean Offshore Wind Turbine Project, and take action to address climate change that is also the way we protect our oceans. And as Ellie suggested, sign up for the Master Climate Protector course and share that with your friends. We're getting close to the beginning of that. Finally, you should have received an email with a survey. It really helps if you'll spend just a couple minutes is all it takes to give us some feedback. SOCAN website is socan.eco. And for questions, info@socan.eco. And if you're able to make a donation, we depend on people like you to keep going. So thank you for everything you do. And thank you for being here this evening. I will stop the recording, and if